Welcome to our discussion of another operations management topic. Today we'll be looking at lean systems, which is chapter 16 as part of our operations management topic discussion. And in this chapter, today's lecture, we'll focus on basic elements of lean production and focus on what are the benefits of lean production, how one goes about implementing lean production in an organizational context. Then we'll also touch on lean services in service environments. Leaning the supply chain as well as Lean Six Sigma will be addressed as well. Lean concept in the environment sustainability issues, and finally we'll also address the value stream mapping tools in this case. Now in terms of lean production, it's the lean system implemented through just-in-time philosophy, and just-in-time is the characteristic of lean production system. And GIT and lean production are used interchangeably, these two words, and lean production just happens to be a larger umbrella within which GIT focuses on inventory and production environment. So GIT itself is a repetitive production system in which processing and movement of material and goods occur just as they are needed, usually in small batches. Doing more with less inventory, fewer workers, and less space. So that's a key idea to eliminate waste. Smoothing the flow of material to arrive just as it's needed, and basically GIT operates with very little fat or unused resources, if you will. And another concept in GIT is the focus on muda, or waste. That's a Japanese word for waste. Anything other than which adds value. So any non-value added component of a production process is muda. So that's how we look at it. So waste in operation happen from variety of things. So you're looking at waste in overproduction. You end up producing more than you need, and the rest goes to waste. Waste of time, which is waiting for parts. So worker is there, remainder of the ingredients are there to produce a product, but you're still waiting for, machine is also waiting, but you're waiting for some parts that are still forthcoming. Waste of transportation. So in this case, you are unnecessarily moving the parts from the warehouse to the shop floor, not using them and then bringing them back at the end of the day. Waste of processing. You produced, have unnecessary steps which do not add value, so thereby the process takes longer time to produce a product than it really needs to. Then having extra inventory, storing, retrieving, counting, ensuring, all that, so there is a waste of material in terms of which takes up space and money in this case. So a few other waste in operation are waste of movement, searching for tools, parts, instruction approval, all that will add up to the setup time in this case. Waste of producing the wrong items, or producing items that are defective, which are no longer valid in the minds of the customer with the wrong configuration. That's rework and scrap is needed, so you had defects. And then waste of talent. You may have workers, but you're underutilizing them in terms of not using them smartly, or using their capabilities, learning from them in terms of what all is possible to improve the system, to do better work environment. Now, in terms of pillars of GIT, so if you think from a Japanese Toyota production system, you have focus is to eliminate non-value activities or elimination of muda. So you want zero muda or waste. So that comes from zero defect, zero breakdown, zero inventory, zero setup. And in this, there are two different ways, two-prong approach. One is the production flow synchronized with demand, GIT, and one unit at a time flow. So that is, as the unit is being consumed, more unit is being produced. Mixed model production, Haijunka, which is being on the same shop floor, you are making two different type of products, or more than two, thereby taking away the need of having the situation where you're underutilizing machinery because you have 3 different production lines for 3 different product variations, and if the demand is not there, you are underutilizing those machines and having that's a waste, which can be easily rectified. Piece-by-piece transfer, ikonagashi as it's called in Japan, and that allows for, as the product, each unit is produced, it's moved to the next station. Match production demand based on takt time, and we'll address that in a later slide. Pull instead of push, which also will be addressed a bit later, in the pull system. And supermarket Kanban, which is focusing on a certain number of units that has to be produced every time we have authorization to produce. Make-to-order environment that you have. And in terms of over here, quality methods to reduce the defect. So this is what we're trying to do is reduce the amount of inventory. So one way is to make sure we don't produce bad quality. So over here, these are all the quality methods to reduce the defects. So foolproofing, Pokayoke, that we discussed in the previous topic discussion, and visual feedback is needed, which is go and see Genchi Genbutsu, as it's called, physically visiting the space and seeing for yourself as to what seems to be wrong, rather than just getting a report on it. Detect stop alert, which is Jidoka, visual confirmation of what's error is, and then stopping it. Defect at machines, which is original Jidoka, and defect in assembly is end-on system of lights, the end-on cord that is used. Built-in quality, Skurikomi, which is actually every product has a certain amount of quality that's inbuilt into it. In this case, flexibility is also incorporated, which is adjustment of capacity to meet takt time. Multitask assignment, Takote Mochi, which is used in terms of production flexibility, flexible production processes. Standardization of work, which is emphasized through reduction of variability, so that consistency of products throughout. The other tools that are used are quartile analysis and standard operating procedures. So more standardization that is used, the lesser chances of creating highly product with high variability. Quality circles, Kaizen is also used in this case, and fishbone diagrams, which are coming from Ishikawa that were discussed in the previous lecture, can be used here. Cross-training and skill development is also one of the components in this case. Now, in terms of lean production, the goals of lean production are to make system flexible, which allow, one of the ways to do is reserve capacity for important customers who are paying the full fare, if you will, which brings in, or important customers without which the company cannot accomplish their bottom line goals. Eliminate risk disruption, minimize inventory, eliminate waste, all but focus, produce on, any waste is anything but value-added activities. Reduce space requirement as a result of that, reduce the number of job classes to minimize them, so that standardization, and make jobs more challenging so that the workers are challenged and they become more smarter and involved in the production process. Develop close supplier ties and educate them. So some of the characteristics in this case are pull method of material flow, which all this will be discussed in the later slides, but just to kind of list them. Consistently high qualities produced, small lot sizes, uniform workstation load, flexible workforce, and processes to help clear bottlenecks or the constraining points in a production process. Stable demand schedule is one of the requirements or characteristics of products that are best suited for GIT environment or lean production environment. Line flow strategy, production line process, and automated production versus automation, which we'll talk about in a later slide. Preventive maintenance and Kanban production control system. So in here, you can see in terms of just in time, it's a precondition is leveled production, Hijunka, that we talked about. And material and information flow is needed, where you need to know what is sold, when it's sold, in the amount sold, and the pace, what is the selling pace that you have. And the Jidoka, which is make good products efficiently, human productivity improvement, and quality assurance. All this will take countermeasures against problems one by one, that is, improve quality on a continual basis, the Kaizen concept. Now, in the lean production concept, we'll focus on the basic elements, about 10 different elements, all the way from flexible resources, cellular layouts, pull system, Kanban, small lots, quick setup, uniform production level, quality at the source, TPM, total productive maintenance, and supplier networks. So in this case, all this kind of leads from elimination of waste. It can be done through increasing flexibility, which are the first 2 items. Then the next 5 items, 3 through 7, are indicated in the smoothing the production flow, and then continuous improvement is the last 8, 9, and 10, which is trying to improve the system that you have. Now, let's go ahead and look at each one of them separately. And in this particular case, you are trying to see flexible resources or Takute Mochi. It's cross-training workers to help clear bottlenecks, which is multifunctional workers perform more than one job in this case. General purpose machine performs several basic functions, and so it is used preventive maintenance to reduce breakdown, reserve capacity for important customers this way, reduce downtime by reducing changeover time, and the 2 ways to approach that is cycle time, time required for workers to complete one pass through the operation assigned, and takt time that was alluded to earlier. If you ever recall seeing a metronome that is used for either dance lessons or piano recitals, etc. So that provides the specific tempo or beat at which the music or the entire orchestra or the piece will be played at. So it's a pace of production, paces the production to customer demand. So this is equivalent of setting that metronome to the demand that is exhibited by the customer. So you're only producing what the customer is demanding, no more, no less. So producing faster than takt time results in buildup of inventory. So cycle time is adjusted to match takt time by changing worker paths in this case. So in this particular case, so typically the idea is to make sure takt time paces the production to customer demand. So in this case, let's just look at it. So the takt time is basically hours available divided by the demand. So this is the H is available is the hours of available capacity, and D is the demand that is coming from the customer. Now in this case, suppose that we have a demand of 90,000. So D is 90,000 units that are indicated. And the capacity is that you have is 38 hours in this case altogether of available capacity, which if you try to calculate that in terms of minutes and seconds, so you have to multiply this by 3,600 to come up with seconds, which if my calculations are correct, I have 136,800 seconds that ends up being. So in this case, what you have is this is your available capacity, but this is in seconds. So you have the takt time is 136,800 divided by total demand of 90,000, and that comes out as takt time of 1.52 seconds. So every 1.52 seconds, you should have one product coming out of the assembly line in order to match your production with your demand that is exhibited from the customer. So that's an example of how takt time is calculated. Notice that normally H available is in hours of available capacity, but if we were to actually calculate this in hours, 38 divided by 90,000, you'll end up having extremely small number in terms of hours, which is 1.52 divided by 3600. So that one is hard to interpret, whereas 1.52 seconds is easy to interpret. That's the reason I converted that into from hours to seconds. So that's an example of what we're looking at in this case. So from a standard operating routines for a worker, you can see a typical day of a worker. You have a worker spending a lot of time on doing a variety of things. You have picking up material, unloading load from machine one, then the machine is working. So this is the actual time where worker is doing something. Then once the loading is being done, that's the time being spent trying to unload the machine. And then once the process starts, it takes this much time. And then unloading of machine 2, 3, all the way to, and this is the production scenario. And then you have inspection, and after inspection packing, and then you have going back to picking up of material, etc. So you can see exactly in 2 minutes exactly how the worker is operating and getting a sense of things. So one can easily look into how this will result in identifying a better way of doing things. One example is the cellular layouts. Manufacturing cells comprise of dissimilar machines brought together to manufacture a family of parts. So in this case, we talked about cellular manufacturing earlier. So in this case, you can see when you have higher takt time, you may need 3 workers producing items. But if the demand decreases, that same amount of work can be done by a completely different cell is being set up differently, which is 4 and 5, whereas the entire cell is being handled by one worker, or they are doing it in different type of machine orders, etc. So you can see in this case how currently in one type of demand environment you have 5 different cells being handled by 10 different workers. But when as the volume decreases, as we are only producing enough to match what the customer truly demands, not just to keep machines busy, you may realize that you need lesser number of people. So it's the same number of machines, but you can see now you have only 3 workers working on variety of machines. So the entire cell 1 is being handled by 1 worker, cell 2 and cell 5 is being handled by worker 2, and cell 3 and 4 is being handled by worker 3 altogether. So instead of 10 workers, you may only need 3 workers, and instead of now you have a modified 3 cells from the earlier 5 cells that you had. So that's workers will end up performing more variety of tasks. It becomes becomes much more interesting for them, more challenging. They feel they are contributing more to the production of for the company, rather than they are working smarter in this case, rather than doing monotonous job over and over again. Now the next concept is the pull system, which is one of the basic elements. A system of moving work where the workstation pulls output from preceding station as needed, and reversal of traditional push system where material is pushed according to a schedule. So in this case, it forces cooperation. That is, we can only produce what the customer is demanding. So one has to really work collaboratively with other workers in order to make sure they are producing exactly what the needs of the customers are. Prevent over and under production, while push system rely on predetermined schedule where everybody's on their own producing whatever is needed. This way, pull system relies on customer request, and which requires a lot more of communication in this particular case. Now let's look at Kanban system. Kanban is a Japanese word for card. Card which indicates standard quality of production. So in this case, It's a paperless production control system derived from true bin inventory system that we'll talk about in a later slide. It maintains the discipline of full production. That is, customer order is paramount and everything is dictated from there. Authorized production and movement of goods, and authority to pull or produce comes from the downstream process from the customer side. The different variety of Kanban: production Kanban, which is authorized the production of goods. Withdrawal Kanban is authorized movement of goods from warehouse to the shop floor or shop floor, from one workstation to another workstation. Kanban square is marked area designated to hold items on the shop floor. Signal Kanban is a triangular Kanban used to signal production at the previous workstation. And material Kanban used to order material in advance of a process. Then you have supplier Kanban, rotates between factory and supplier, maybe go with the truck or with the order itself. So this is an example of a Kanban tag, which is attached, in this case, from Nippon Denso and actually Japan. And you can see exactly the type of information which has barcodes, which can be scanned and entered as it reaches a particular destination and triggers the new authorization of new work or movement of parts. So origin of Kanban, the two-bin inventory system, you can see back from our discussion of inventory management, we start producing as soon as we reach a reorder level. So you end up creating two bins. If we have a total of quantity Q we carry, Q minus R is kept in one bin, and R is the reorder point, which indicates how much time will it take, how much quantity will it take to satisfy, to suffice during the lead time for supply from the supplier. So that's the R which is kept in here. So as soon as you finish the end of bin 1, that's where the reorder card is, and that's where you place the order. And while the order is coming through, you are consuming this inventory. Similar to the reserve fuel gauge in a vehicle. As soon as you get the reserve fuel gauge, it gives you at least enough gas in the vehicle so that you can search for a gas station and get the car filled. Whereas Kanban is slightly different. All you carry is inventory R, and this is as soon as the start of it, you place an order. So by the time you finish through R, another quantity R comes in, and so on and so forth. So in this case, the orders are the signal is being based in synchronize with what the customer wants. The Kanban signals, in this case, you can see exactly the customer orders, in terms of which is dictating how much is going to be shipped. The finished goods are coming in here, and the Kanban is being released from the customer. If the customer picks up the product, that will reduce the inventory over here, which will trigger final assembly. As soon as the final assembly area picks up release the Kanban, because they are picking up sub-assemblies to make the final assembly. These are triggering Kanbans to go in so that these guys can also start producing the sub-assemblies from the raw material. So the Kanbans are moving back, which are authorizing work, and the actual work is being created, which is moving forward. And another way of looking at this, in this case, is you have the assembly line where it's storage, and so once the production Kanban is received, the machine center produces a unit to replace one taken by the assembly line. So over here, this machine starts producing, so it takes item from storage that releases the withdrawal Kanban to this area, which once you move the items from storage part A of this machine center to here, that releases the production Kanban for this machine center to produce one item and put it in here. So that's the movement of production Kanban and withdrawal Kanban back to synchronize with what the production is actually happening which is being dictated by the final customer in this case. So single card Kanban system is each container must have a Kanban card. This is an example of a Kanban card, if you will. Assembly always withdraws from fabrication to the pull system. Container cannot be moved without a Kanban, which is the authorization. Container should contain the same number of parts. Only good parts are passed along. Production should not exceed authorization. Then you can use a dual Kanban system, which is withdrawal and production that I mentioned earlier. Other type of Kanban are the Kanban squares, where items are produced in the certain square, or Kanban racks, if you will. And there is another variation of signal Kanban that is actual a flag, similar to what you see in state fairs, where you have the height rack. If a teenager or a kid does not meet a certain height requirement, they cannot go through to the Ferris wheel or some minimum height requirement rides. So over here, as soon as you reach a certain level of material and it goes below a certain height, that indicates for 409, that's the height limit, and so that's where you have a signal to order a new Kanban. And so you can take that various Kanbans, whether it's a square or triangle, to taken out and actually indicate. Kanban post office, a central repository where keeping track of exactly where things are, and more Kanban cards are needed, and they can be replaced or monitored at the same time. Other Kanban concepts: when producer, user are not in visual contact, a card has to be used. When the producer and user are in visual contact, a light or flag or empty spot on the floor may be adequate. Since several components may be required, several different Kanban techniques may be employed in this case, as I pointed out. Usually each card controls a specific unit of parts. Multiple card systems may be used if there are several components or different lot sizes. Kanban cards provide a direct control and limit on the amount of work in process between cells. In an MRP system, the schedule can be thought of as a build authorization, and a Kanban a type of pull system that initiates actual production. And if there is an immediate storage area, two card system can be used in this case. So let's look at determining the number of Kanbans. Setting up a Kanban system requires determining the number of Kanban cards. So each container represents a minimum production lot size that you're going to be producing every time a Kanban is released. So accurate estimate of lead time requires to produce a container is key in determining how many Kanbans are required. So you're looking at the calculation for number of Kanban is average demand during lead time plus safety stock. When added together, divide that by container size. So you have average demand during lead time, which is D, periodic demand times L, lead time, plus the safety stock, divided by C, which is the container size of the container. So in this case, let's look at a specific example. Let's say we have 150 bottles that are being produced per hour, and lead time is 30 minutes, which is in the same time notations, it's half an hour. S is 10% in this case of 150 times half an hour. So you're looking at you want 10% of the total production during lead time in safety stock. So in this case, 10% of 150 times half an hour is 7.5. So this is 75 over here, plus 10% of that is 7.5. That's how this is being calculated. So in this case, you are looking at a container. One container carries 25 bottles. So you have 75 plus 10% safety stock, which is 7.5. Put together, altogether, that's 82.5 divided by 25. That's 3.3 Kanbans, which always has to be rounded up. Even if it is 3.01, it has to be rounded up to 4, so to allow for some slack. But if in case you really are sure you can create an improvement, a Kaizen improvement, then in that case you can always go down to 3 if it's not too much or not too improbable. Now, operational benefits of Kanban are problems are immediately evident And in this case, allow only limited amount of faulty or delayed material because Kanban, as it says, it requires a very few amount of items that are being moved forward or authorized to produce. So if any changes happen, it will only affect to that small inventory. Put downward pressure on bad aspects of inventory and standardize container reduces weight, disposal cost, waste space, and labor, and reduce paperwork and simpler planning systems that are being in place. Now, in terms of the next aspect for elements of lean production is the small lot, which we talked about earlier. So in this case, small batch production is an important approach to matching production rate to demand rate. When you produce in small quantity, you have a better chance of not overproducing and keeping the waste to minimum. Producing in more frequent smaller batches drive the average inventory level down, but it also increases the number of time equipment must be changed over, which can cut into available capacity because the setups are required. Small batch production becomes economic only when changeover times can be reduced sufficiently. So that's one of the key goals. So, but also small batch requires less space and capital investment, and it allows for process to be moved closer to each other, thereby you don't need that much of factory space. Because most of it is being used in warehouses or storing in material. Make quality problems easier to detect and make processes more dependent on each other. So here is an example, visual example of how if you have the river filled up, even though there are boulders in the bottom of the river, which indicate all the potential constraints that a typical production process so this is the river of inventory. When you have enough inventory, even if there are lengthy setups, machine breakdown, poor quality, all those things are buffered or do not factor in terms of availability of raw material or inventory for production. So all those mistakes are kind of swept under the rug, if you will. But when you force to have less inventory, all of those things become evident, and so one has to be more careful and more coordinated in their workplace so that they don't end up being hit by these constraints. So these problems get exposed. So while you're trying to, on a daily basis, trying to work around these problems, in the long term, the Kaizen teams are trying to figure out how to eliminate these potential constraining factors. So components of lead time, in this case, you have processing time, which is reduce the number of items. So how we take care of processing time, number of items or improve efficiency, thereby you have more availability of processing time. Move time, one way to have that, minimize the impact of that on the total availability of time is to reduce the amount of distances machines travel or workers travel to set up or move the product, if you will. Simplify movement, standardize routing. Waiting time, better scheduling, sufficient capacity will minimize the effect of that. And setup time, that typically is the biggest bottleneck, and that can be addressed by using quick setups. So in this case, high setup cost encourages large lot sizes, but reducing setup cost reduces the lot size and reduces average inventory. Setup time can be reduced through preparation prior to shutdown and changeover. For example, when you go to restaurants, you may see during lunchtime or after lunchtime, after the restaurant is closed, maybe the staff will spend time trying to prepare the silverware wrapped in a napkin in advance for the evening rush hour. So that's a way of prior preparation, if you will, equivalent, so that the changeovers become easy. Internal setup can be performed only when a process is stopped, and external setup can be performed in advance ahead of time. So single minute exchange of die is a principle, SMAD principle. Separate internal setup from external setup. Convert internal setup to external setup so that you can perform things in advance. Streamline all aspects of setup and perform setup activities in parallel, eliminate them entirely. Okay, 13? 1, 3? Okay. So in this case, you can see from this visual relief how setup time, one can reduce the setup time. So you have initial setup time of 1.5 minutes, which once you separate the setup into external and internal, into preparation and actual setup, doing as much first things in advance, you can easily save some considerable minutes over here. Then in the second step is move material closer and improve material handling. That can also decrease this number substantially. And then third step is standardize and improve tooling. That example is single minute exchange of die. That can reduce the number considerably. Then use one-touch system to eliminate adjustment, further improvements, training operators and standardizing procedures, and repeat cycle until sub-minute setup is achieved. So there are a lot of ways to do that. Here are certain techniques that go a long way in this case. Preset desired settings, so that just like a lot of vehicles come with memory functions for desired settings for the seat, so that the driver does not waste time setting the seat, so that if there are two drivers in the household, the car will remember based on which key is put in the ignition, it'll remember what are the driver seat settings. So that's an example of pre-desired setting. Or quick fasteners, easy to attach or detach, like key rings that allow keys to be added easily rather than making it harder. Locator pins, so they become self-guiding like Lego blocks, so that easy to, there is only the right way to put them together. Prevent misalignment, so making sure Poka-yoke, one of these plugs is larger, wider as compared to the second one, so that there's only the correct way of inserting things to avoid ill effects of doing it the wrong way. Eliminate tools, snap connectors rather than screw-on connectors, and then make movement easier. Exchanging the drawers so you can put any drawer in any of this crevice over here, openings. Now, uniform production levels result from smoothing production requirement on final assembly line. Kanban system can handle plus or minus 10% demand changes and reduce variability with more accurate forecasts, smooth demand across planning horizons, and mixed model assembly studies component production. Here is an example of mixed model sequencing. So you can see September sale forecast is for a variety of parts at different colors of various products. So you can see some vans, some SUVs, some cars, and of different colors. So in this case, mixed model sequencing is you're putting different color, different model, all being, in this case, all the SUVs are being put first, then vans, then cars. But mixed sequencing is sometimes you're putting a different SUV, after that a sedan, after that another SUV, then van, depending on how often things are needed. So in this case, that allows for much better use, only producing just what is needed in this particular case. Quality at the source is another tool which is focusing on visual control, make the problems visible, as we pointed out earlier. Poka-yokes is preventing defects from occurring in the first place. Some inadvertent errors, we try to avoid them. Kaizen, we talked about it in a discussion of quality management. This is a system of continuous improvement, changes for the good of all on a continual basis. Jidoka is authority to stop the production line as needed. And end-on is a call lights, a signal quality problem, so that everybody's aware there's an error happening, and without actually somebody verbally communicating that, everybody can see it for themselves. Under capacity scheduling, so it allows for some last minute capacity available for some important customers or for problem solving, planning, and maintenance. So other examples of visual control, you can see tool board where you can create an outline of various tools. So it indicates the ideal location where different tools go in, and anytime a tool is missing, you know what is missing from the board in this case, and if things are not being located correctly. Visual Kanbans indicating what the levels are and if we are below or above a certain level. If in terms of certain, from a sensor, if items are not the right weight or right dimensions, there is a warning light that comes on. On a library shelf, you can, rather than noticing every single volume and indicating volume 1, 2, 3, reading them, but if you were to draw a diagonal line, as long as the line is smooth, you know every single book in the shelf is correctly in its right place. Other examples of machine control. So you can see, you can read the dial and indicate, oh, it's between 30 and 50. But if a better is by pre-indicating exactly, what their danger zone is. And the third one, best is Pokayoke, is not only visually it tells you where things are, but also by a light if it reaches that point. Another very valuable tool is the 5 whys, as explained by the textbook. A key part in effective Kaizen is trying to keep doing brainstorming as to why it happened. And you provide an answer to the first why, then you say, okay, why is that? You keep asking. At the 5th level, you pretty much have found the source of the problem. So the practice of asking why again and again till underlying cause is identified usually requires 5 questions. So simple yet powerful technique for finding the root cause of a problem. Now, in terms of total productive maintenance, one is breakdown maintenance, repairs to make failed machines operational. Second is the preventive maintenance, system of periodic inspection and maintenance to keep machines operating and stopping them from failing in the first place. So TPM combines preventive maintenance and total quality concepts. The requirements are design products that are easily produced on existing machines, and design machines for easy operation, changeover, and maintenance, train workers and retrain them to operate machines so that they are producing them in the correct way, and purchase machines that maximize productive potential, design preventative maintenance plans spanning the life of machine in this case. So here is an example of the 5S workplace scan that is indicated in case of coming from Japanese production system. Sairi is sort, which is keep things on, keep only items that are needed. Unneeded equipment, etc., should be sorted out and put it in the right areas. Set in order, a place of everything and everything in its place. So if items are not in the correct places, then it should be obvious. They should not be just lying around, thereby making it harder to focus on minimizing time wasted on searching for the right items. Shining, which is making sure the workplace is clean and organized. Seiketsu is standardized, maintaining and monitoring the first of the 3 categories, making sure we make a habit out of doing these. And then sticking to these rules, sustaining, or Shitsuke is sustaining these practices over the life. Additional to these, there are 2 more that have been identified as part of the lean production. One is basically safety. So the 5 S's plus number 6 is safety, or anzen, as they call it in Japan, and that is basically workplace safety that is needs to be done, and then finally support or maintenance, which is SEBI. So again, these are the Japanese words for these 2 additional terms to make them 7 S's, if you will, and just to kind of have certain elements of how to make sure the workplace is set up so that the right items are being done in this case. Another tool that is used in this case is employee empowerment, which is make people more empowered so that they actually can work smarter and intelligently to figure out what needs to be improved in the whole. So empowered employees bring their own knowledge and involvement to daily operations. Some traditional staff tasks can move to empowered employees. And training, cross-training, and fewer job classifications can mean enriched job in this case. Companies gain from increased commitment of employees in many cases. In this case, we will, one of the other as elements of lean production is the supplier network, where you have few supplier located in close proximity to the customer, repeat business with the same supplier, mixed load and frequent deliveries. So suppliers are working as partners in this case. Precise delivery schedules, standardized sequence delivery, long-term supplier contracts, synchronized production and supplier certification so their quality is being measured. And in this case, related to that is the GIT partnerships with the suppliers. The GIT partnerships exist when purchasers work with suppliers in a supplier network to remove waste and drive down cost. So support suppliers so they become or remain price competitive. Competitive bidding mostly limited to new purchases. Buyer resist vertical integration and subsequent wipeout of supplier business. So they are working as partners. Suppliers encouraged to extend GIT buying to their suppliers. It's a supplier. And successful GIT partnership requires elimination of unnecessary activity, elimination of in-plant inventory, and in-transit inventory, and also elimination of poor suppliers. So now let's kind of look at the benefit of lean production. So in this case, why lean productions really help out in the operations management environment. First of all, they offer reduced levels of inventory, which results in improved quality, and of course lower cost if we don't have inventory investment, which is actually just sitting there and not adding value. Reduced space requirement because of the lower inventory, and increased equipment utilization. You can get rid of the remaining equipment, and then equipment can also be used in more meaningful ways. Shorter lead time, we talked about smaller lot sizes leading to that. Increased productivity, greater flexibility. A better relationship with supplier that we just discussed earlier. Simplified scheduling and control activities. Valid priorities for production scheduling. You're actually producing that actually is going to be sold rather than something that's going to sit in a warehouse. Increased capacity because you're not making people create busy work for them, but only if they're producing what is needed. Better use of human resources, making workers work smarter, and that's where the workforce participation comes in. And also, you can accommodate more product variety with mixed model sequencing. Lean production aspects, implementing lean production, use lean production to fine-tune an operating system, somewhat different in USA than Japan in terms of its implementation. It's still an evolving field. It keeps changing as companies hone their processes and practices in this area. And it's not really meant for everybody. If the demand is highly variable, it's not a great choice of use of lean production process in that case. Lean production problem, as I mentioned just a minute ago, highly variable demand environment, you will see lean production will not give you the best results. Large variety of low volume products also make it harder to use lean processes, and custom engineered products also will be another area where lean will not deliver well. On the other hand, mass produced part, or unexpected change in demand and supply. Any one of those scenarios will make a lean not a good choice of process to be used. Let's move on to our discussion on lean services. Basic element of lean production applied equally to services, and in industries, in service industries, more leading the charge are retailing environment where lean retailing is used, and lean banking and lean healthcare has been coming into where many of these lean principles are being put into practice. In terms of leaning the supply chain, several approaches. We have pulling a smooth flow of material through a series of suppliers and support frequent replenishment orders and changes in customer demand. So the entire supply chain can work collaboratively to accomplish that. Firm needs to share information and coordinate demand forecast, production planning, and inventory replenishment with suppliers. So trust is a very important. So not only with supplier, but suppliers throughout the supply chain. So if the trust is not there, this lean approach will not work. Pooling a smooth flow of material through the system, build a highly collaborative business environment, adopt the technologies to support your system, and consider near-shoring, which you mean putting the workers or suppliers near, co-locate them to where the production processes are. Lean Six Sigma and value stream mapping is, so in terms of Lean and Six Sigma are natural partners for process improvement. Lean eliminates waste and creates flow, more continuous improvements, whereas Six Sigma also does the same thing, focuses on reducing variability and enhancing process capability, requires breakthrough improvement. Now let's talk about the value stream mapping, which is a tool for analyzing process flows and eliminating waste. So specialized icons related to lean production, material information flow, and the Kaizen burst, whereas identification of continuous improvement opportunities. So here is an example of various value stream map shapes that are available on software, which can be used to create a value stream map. So a variety of things that can be used in this taxonomy. And for milling and welding area, you can see one can easily look into exactly how much time is being taken and how much time is being spent in the inventory versus the actual value-added process, then more inventory waiting, and then welding process. So that can be looked into and seeing lead time and what is the number of value-added minutes are basically 2 minutes plus 4, which is 6. So in terms of pounds, material needed is 85, and material used is altogether is some of it is weighting. So that's 135 in weight used in weighting and 85 used in this case. So that way it gives you an idea of, so for 6 minutes of work, you're looking at 900 minutes of lead time, 5 days over here and 10 days over here, which translated into minutes is ridiculously long number of minutes. In terms of emergency room, you can see the same thing. Value stream mapping can be calculated in terms of patient arrival to triage, nurses triage to register, through registered nurse exam, etc., to doctor's exam, lab test, doctor orders. You can see the amount of total minutes spent by the patient versus the value-added time, where the value is delivered is only 40 minutes. So that pretty much wraps up our discussion of lean production, and we'll see you in the next discussion at a later time when we cover another topic on operations management area. Thank you.